Right, hopefully this will work and you can watch it back. So what, right, pick a year. What paper do you want me to go through?
The 18.
Last year's paper.
Yeah.
Okay.
The American accent and all that.
The elephant.
Who was that?
The
What's your way now? The toilet?
Just prancing for a pee.
My Katrina Francis before
Yeah.
tea. It's all being recorded, you know. Everyone's laughing at
Bottle of water and inhaler.
it. Come on.
I said, do I think about me saying my elephant prancing for a pee and I just like got run out of the room.
If that helps you remember, good.
What?
Right, so
Then Gavin left the room.
Here's last year's paper, and the first question on last year's paper. Elements are composed of atoms which consist of three types of subatomic particle: protons, neutrons, and electrons. What is meant by an element? Right, so somebody tell me what an element is. An element is a substance that contains one type of atom. And if you wanted to give me a fancy pants definition, you'd say an element is a substance that contains one type of atom which all contain the same number of what? What makes an element an element? What makes carbon carbon?
Proton.
Number of protons contains this. So that's a better answer than what you've probably been asked to give, okay? So an element is a substance that contains the same types of atoms. The thing that makes them the same types of atoms is the number of protons that are there. So if you want a fancy pants answer, you tell me the number of protons. You probably don't need to. So the second thing it asks you to do is complete the following table, given the properties of a proton, neutron, and electron. So we'll go for the masses first of all. Gives me the mass of a proton. For some reason it's a positive mass, as if it could be a negative one, but there you go. The mass of a neutron is the mass. Mass can't be a negative mass, so it has to be 1. So protons and neutrons are the same mass, more or less. And the mass of an electron is 1 over 1850. 1 over 1850. What is the charge of a proton? Okay, so we'll have 1, 1, and 1 over 1850. Charge of a proton is plus 1. It can be a positive or a negative charge. The charge of a neutron is 0. Charge of an electron is.
It gives you a minus.
Oh, it tells me it's minus 1. Okay, and then it asks me for the location. So it tells me that the neutrons are in the nucleus. Where are the protons? And the electrons are in the shells, or anyone know another word? Or orbitals. Yes, suborbitals, but orbitals. Okay, so if you can tell me what an element is and you can tell me where those things are, you've got 5 marks so far. Okay.
It's not enough.
It's not enough. There wasn't much more than 5 available.
But if you do the next part, you've got 24.
24 marks for this. Okay, so 24 marks. This is a lot of marks, okay? So it asks me to work out the atomic number and atomic mass and number of protons for these elements, okay? So what am I going to do? I'm going to get my periodic table out, okay? And I can't draw on this board. So here's my periodic table. Here's my periodic table, and the question asks me what? The question asks me what's the atomic number of fluorine. So I find fluorine on the periodic table, and the atomic number is the big one or the little one?
Big one.
Level.
The little one. Atomic number is the number of protons. Okay? So atomic number is the little one, Renata. And the atomic number for fluorine is 9. So for reading the periodic table, you get a mark. And it asks me for the mass number. Do you know what I'll do, in fact? Periodic table. This is the periodic table that you're going to be given.
Can we take up like a periodic table
So the
in?
It's
No,
mark up
you're
there.
given one.
Yeah, well, it gives you this on the back of your paper.
Okay, okay.
So here's the one that you're going to be given in the exam. Okay? And it's.
Indeed.
I copied that, didn't I? And it tells you that the mass number is 19. So this is a 9. This is 19. The number of protons is the same as the atomic number. So the number of protons is 9. The number of neutrons is 10. And the number of electrons is 9. It's an atom. So remember, atoms are neutral. So the number of electrons must be the same as the number of protons and the number of neutrons, okay? And if you couldn't remember that, remember that each one of these little numbers up here, each one of these superscript numbers is the number of electrons. So there's 2 electrons in the 1s, there's 2 electrons in the 2s, and there's 5 electrons in the 2p. So 2 and 2 and 5 is 9. Okay? So the second one is calcium 2+. So it asks me for the atomic number for calcium. Atomic number for calcium is here, is 20. So I put a 20 in here. It tells me the mass number is 40. The number of protons is the same as the atomic number, so that's 40 as well.
No,
No.
no, it's 20.
20.
Number of protons, 20. Number of neutrons,
20.
why?
Because it's 40 keep going high.
Yeah, it's the difference between the two. And the electronic configuration for Ca2+. Okay, so calcium 2+. So there's my periodic table again, okay? Calcium is over here. It's in what row of the periodic table?
1, 2, 3, 4.
It's in the 4th row of the periodic table, okay? Where's my wee cloth?
Inside your pencil case.
Ah, thanks. So the way that I would answer this question is I would draw out my orbitals. I would say, I would draw this out. And go, here's my 1s, here's my 2s, my 2p, my 3s, my 3p, and then my 4s, okay? And I would say, well, how many electrons have I got? I've got, it tells me in the question, it tells me I have 18. So there's 1, 2, so there's 1 Aufbau principle, there's 2 Pauli, remember doing this with me? Aufbau, Pauli for 4, Aufbau, Hund, Pauli, 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 Aufbau, Pauli, Aufbau, Hund, Pauli, 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 Aufbau, Pauli. How many have I got? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's more than I need, isn't it? So which, so it's Ca2+, so I've lost 2 electrons. Which 2 have I lost? Top 2. So what have I got left? I've got 1s. How many electrons are in it? 2. I've got 2s. How many electrons are in it? 2. I've got 2p. 6. 3s2. 3p. 6. Okay? That's the way that I would answer the question. Okay? Another way that you could think about answering the question, if it's a wee bit easier for you, you can say, here's the ones, okay? So first row's all full, that means that all the orbitals there are full. The only thing that's there is the 1s. Here's the 2s orbital, it has to be full, so it has to be 2s2. I've over here, and here's my p orbitals. So here's the two p orbitals. All of these have to be full. So it's 2p6, and then 3s2 has to be full. 3p6 has to be full, and then calcium should have the 4s2, but it's lost 2 of its electrons, so the 4s is empty. Okay, so here's my s orbitals, here's my p orbitals, and here's my d orbitals. Okay, the easiest way I think to do it, as long as you can remember the pattern, 1s, 2s, 2p, 3s, 3p, 4s. What comes after the 4s?
3D.
3D.
3d, yeah. Okay, does that make sense to you? Any questions there? No? It's going to be a great video, this, and you walk over to it every 2 seconds. Okay, so what I want to write down in my answer box is 1s2, 2s2, 2p, p6, 3s2, 3p6. Now if I wanted to be a smart ass, what could I write? Anybody want to be a smart ass? Why would that be right?
Because it's got the same amount of electrons.
It's got the same electronic configuration as argon, remember, and the Kirkhand way of doing it is going to the last noble gas that you have and then writing down whatever extra that it has. Okay? I would advise against it.
Yeah.
But okay, so sulfur. Next one is S on the periodic table. So I find S. How many, what's the atomic number for sulfur?
16.
Is 16. The mass number for sulfur, go back to the periodic table that you'll be given, is 32.1.
Do you write 32.1?
Well, it says 32.1 on the periodic table, so I'm going to write 32.1. It tells me the number of protons is 16, the number of neutrons is 16. How many electrons does sulfur have?
16.
Why?
16 protons.
Because there's 16 protons and there's no charge. Okay? And what's the electronic configuration for sulfur? So what am I going to do? I'm going to draw this out again. And I would draw it out as many times as you possibly can. Okay? So 1s, 2s,
You scrap paper.
2p, 3s, 3p, 4s, and then remember your 5d goes below your 4s if it's getting filled. So I always go as far as 4s and then stop and only put in the 3d orbitals if I need to. Okay? So 1s, how many electrons am I looking for? 16. So Aufbau, Pauli. Aufbau, Pauli. Aufbau, Hund, Pauli, Pauli, Pauli. Aufbau, Pauli. Aufbau, Hund, Pauli, Pauli, Pauli. I've got 2, 4, 6, 8, 10, 12, 14, 6. So I'm up here somewhere, aren't I? Okay, so this is where I want to be. 2, 4, 6, 8, 10, 12. I need 4 more. Yeah, for 16. So the first one goes in, second one goes in, third one goes in, fourth one goes in, and that gives me my 16. Okay, so what I want to write down is 1s2, 2s, 2p, 3s, 3p, 4. Yep. Yes.
I have a question about mass number.
Yeah.
It's like if I will write just 32.
Why
which
would
will
you
give
write
it-
just 32?
Because definition for that is protons sum with neutrons
Yes,
like
but
16 plus 16 is 32.
well,
not
if you wrote down 32, I
32.1.
don't think it'd be marked wrong. But I don't want you so.
Because I'm getting that mass number by add protons and neutrons.
Well,
I'm not looking in
You
the
can,
periodic
so you can do
table.
that, but why not just look at the periodic table? You're not, you're not going to be marked wrong, Renata. Okay, there's no way that they can mark you wrong. Okay,
Okay.
so you can write 32. if you're doing it your way and you're going, well, there's 16 protons, there's 16 neutrons, they would make up the mass, so it has to be 32. Or you can just look at the periodic table and write down whatever number it is, because that is the atomic mass, the number that's on the periodic table. It's an average because of isotopes, and there'll probably be a question here about isotopes in a minute. But either way, you're fine, okay? So yes, in your paper, you'll be given, you can ask for paper, okay? And if you're writing down anything on spare bits of paper, what do you do with the spare bits of paper? You put them into your paper and you hand them up, okay? See, if you wanted to do your whole paper, instead of writing on the sheet, if you want to do it in the booklets that they'll give you out, I'd be happy for you to do that. Okay, just make sure the question number's written down beside it. So here, what I want is 1s2, 2s2, 2p6, 3s2, 3p4. I'll go down to the next one, and the question is manganese. So it tells me the atomic number for manganese 3 plus is 25. So how many protons are there? 25, it's the same. How many neutrons are there? 30. How many electrons are there?
22.
How many?
22.
And why is it 22, Renata?
Because it's plus 3.
Plus
so
3,
it's
so I have lost 3 of them. Perfect. Perfect. So manganese, what have I got? I've got 25 electrons, no, 22 electrons I need to put in now. Okay, so what I'm going to do on my booklet that I ask for is I'm going to draw out this before I do anything else right up to 4s, okay? And then I'm going to put my electrons in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I need 2 more, okay? So they're going to go into my d orbitals. So I'm going to say 3d. How many d orbitals are there?
10.
10 electrons, 5 orbitals, suborbitals. So I need 2 more. So 1 and 2. So what I want to write down is 1s2, 2s2, 2p6, 3s2, 3s2, 3p6. Right?
Can you write 4, 4, then 3?
Well, which is lower?
3.
So it's 3d 2 4s2. Okay, so draw it out this way. Draw it out. So honestly, remember, draw this out hundreds and hundreds of times before the exam. So this picture, and draw it out up until 4s. Leave a space for the 3d in case you need them, but draw out up to 4s. Add in your electrons. If you've got more electrons than what you've got space for, then add in your 3d orbitals and start to fill them up, and you'll not go wrong. So the next one is phosphorus 3 minus. So it tells me its atomic number is 15, mass number is 31. How many protons are there, Emma?
Sorry,
Number of protons.
protons, 15.
15 is right. How many neutrons are there, Katrina? 16 is right. How many electrons are there now?
18.
18. Why?
Because 3 minus.
3 minus. So it should have, if it was an atom, it would have the same number of electrons as protons. It's got 3 minus charge, so it has 3 extra. And then if I want to write down, can you see me on that screen? Yeah?
Yeah.
If I want to write down the electronic configuration like this, start off doing it this way. So 1, 1, 3, 1, 3, 1. How many do I need? 18?
14, yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. So what I'm looking for is 1s2, 2s2, 2p6, 3s2, 3p6. And copper plus. So I'll go to my periodic table and I'll find copper, Cu, and it tells me the atomic number is 29. Mass number is 63.5. number of protons is 29. So if you want Renata, you can add 29 and 35 together and you can come up with 64. Okay?
Why atomic number is 29?
That's what it is on
Because
the
that's what it is on the periodic table. Use the periodic table to do it. Don't try and work it
I
out using.
don't have.
See
You will in the exam. You will in the exam.
See the third one up. It's 55.
Yeah.
And it's 55.1.
On the periodic table.
But
Yeah.
then
But it
that's the
told
answer
me
they
it's
give us.
55.
I know that there, but if they're doing that, not putting in the.
You put in the number that's on the periodic table. Okay? You
Or work it out
even
from the periodic,
you
even
put
though-
it in.
Just to double check that.
No, put in the number that's on the periodic table. So copper plus. Has it lost electrons or gained electrons? Lost. So how many electrons does it have? It has 28. So I, on my piece of paper, go 1s, 2s, 2p, 3s, 3p, 4s, and then I fill my electrons up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm after 28 of them. There's my 5, okay? So I say I need 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Is that right?
No.
Why is it not right? Copper's different, okay? So the more stable, look, I've got all filled orbitals apart from this one over here, okay? I've got 2 singly occupied orbitals, okay? And it doesn't really like this. So if it can fill all of its orbitals, it'll try and fill them all. So what it can do is it can take its 2 4s electrons and it can move them down and it can have a completely filled orbital, okay? Does that make sense? So it's
Is that only for copper?
no, it's copper and chromium. Okay. So if you get a picture like that, we've got 2 left over or 1 left over. If I had 1 left over, so if I had this, what would have happened? It would take 1 down, and then what you would have is
So-
everything completely full and 1 thing half
If it
full.
was copper ordinary, then that would be,
Okay, so remember, it wants to, if it can, it wants to have completely filled or half filled orbitals, and it will change the 3D and the 4s in order to do that. And the reason it can do it is because the energy difference between the 3D and the 4s is really small. Okay? So what I want to write down for my copper answer is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Yep. Okay, so the table,
There's 30 marks. What do you need to pass?
the table below shows the relative abundance of the 5 main isotopes of calcium, okay? Now, what is meant by the term isotope? So an isotope is an atom of an element that contains a different number of neutrons. Remember, the thing that decides which atom it is the number of protons, okay? The thing that decides whether or not it's an atom or an ion is the number of electrons, and the thing that it decides that whether it's an isotope is the number of neutrons, okay? So isotopes have the same number of protons, the same number of electrons, but different numbers of neutrons, okay? What's the neutron's job?
We don't need to know that.
It's the glue, remember, it's the glue that holds the nucleus together. So the neutrons hold the nucleus together. So sometimes you can have 15, sometimes you can have 16. Both of those amounts of glue is fine. Okay?
So what's the definition again?
So the definition for an isotope is an element that has the same number of protons and electrons but different number of neutrons. So same protons, same electrons, different numbers of neutrons. And then if you want, there's not much room here, but if you were answering it on your spare sheets, you could say the properties of both are identical because neutrons don't decide the chemistry.
So the same number of electrons, protons. what's
Same number of
different?
protons, same number of electrons, different number of neutrons. Yes, you need to know it because it's on your course. Calculate the relative atomic mass of calcium to 1 decimal place. Okay, so what I want to do here, I want to go up and I want to say, okay, the way that I calculate the mass, the relative mass is, I imagine I can divide them up. I've got 100 of them and I divide them up into little piles. And then I take the weight of each pile, add the total weights of all the piles together and then divide by 100. Okay, so that's what I would do if I could hold them, but I can't hold them. So instead what I do is I take the mass, so the first one is 40 times, if I had 100 of them, how many? It's the mass times the abundance, okay? So it's 40 times 96.94. Anyone got a calculator?
Yeah. 3877.6.
3877.6. And then I do the second one, I say 42 times 0.65 equals,
27.3.
say again?
27.3.
No way. 27.3?
Really?
Might be a bigger number. Oh, it's 0.65. Go. Next one is 43 times 0.14.
6.02.
6.02. 44 times 2.1 is 90.
2.4.
92.4, and 48 times 0.17 is 0.9.
8.16.
9, 8, 8,
8, just 8. It's not
9,
9. It's
oh, 8, 9, 1, 6.
No, 8.16. There's no 9 in it.
8.16, yeah?
Yeah.
I got there in the end. Right, so I know how much each pile of my little atoms weighs, and now I add them all together. So I add all of these numbers together and get the total.
4011.
4011.
0.48.
4011.48. That's the mass of 100 of them. So to find the mass of one, what I do is divide that number by 100, and I get 40.11.
So it's the 1 decimal place, so it's just
It
40.1.
says 1 decimal place.
Yes, just
so
the point
1.
1 then.
And how do I check my answer?
Sure.
I go to the periodic table and I look up calcium.
Yep.
Look up the mass of calcium, and on the periodic table it tells me it's 40.1.
How do you know it's 100 though?
I imagine
That's
there's
what
100.
one
I
is,
imagine.
Adds up to 100%, does it not?
Yeah, it does.
Right, okay.
So don't just, if you're struggling with it, Katrina, just learn the method.
You just know you
So it's 100. So the way that it's easy to teach is you say, imagine you had 100 of them. And usually when you say that, it works out that these numbers are whole numbers. So here I wouldn't imagine I had 100. Here I would imagine I have 1,000 of them. And if I did that, I would have all whole numbers and then I would divide by 1,000. But don't complicate it that way. So it's the mass multiplied by the abundance.
Yeah.
Add them all together, divide it by 100, and that's your answer. And then check your periodic table, and if your answer is a mile away, if your answer is a little bit away, you're probably still right. If it's miles and miles away, you've made a mistake, so look at it again. Okay? So that was 4 marks. And why is there no difference in the chemical properties of isotopes of carbon?
Atomic numbers,
Because atomic number is the same as an okay answer. Can anyone give me a better answer?
protons. Because neutrons does nothing.
Because, well, but what does something? What does the chemistry? Electrons. Okay, so here you want to say something along the lines of the protons, the neutrons don't affect the chemistry. It's a calcium because what? What makes it calcium? Protons. The number of protons. Okay, so it's calcium because it has a certain number of protons, and it's an atom of calcium because it has a certain number of electrons, and they're the two things that affect the chemistry. The neutrons don't. Okay. So you want to say Neutrons don't affect the chemistry because they don't.
Would that be for any?
Would that be for like
type of-
any, you know, element?
Anything you want. It's electrons that do the chemistry.
And it's towards if you get acid and any isotope, it's all.
It's always
Yeah.
neutrons don't matter. And then if I was to have my wee lecture here, I'd put up one of them wee stars that you all love so much. To say that actually sometimes you
It will
can.
be a question like that in an exam.
There could be.
Could be or it will be.
I can't tell you if there will be. There could be.
There usually is an isotope.
Yeah, if you look at the past papers, there's usually an isotope
Oh,
question, so it's
like
definitely
that,
yeah, like that. Okay.
Yeah.
So what was I going to say? What was I going to say before I was asked to tell you what was on the test? I was going to say something, and then Renata says, "Will that question be on the test?" And I lost my train of thought. I'll just go on. Right. So potassium is a reactive metal found in group 1. Using a label diagram, explain the bonding present in potassium. Okay. So
That's your what now?
right. So potassium is group 1. What's group 1 called? Anyone remember? Okay. Alkali metal. The important thing I want to know there is that it's a metal. Okay? So what is metallic bond? And you want to tell me about metallic bonding.
Delocalized electrons.
So delocalized electrons. So you want to draw little spheres. And you want to say that these are the what? Ions. Okay, what ions are they? They're potassium, so they're K plus ions. And then surrounding these, so I could colour this in. Is what sort of cloud of electrons? So delocalized cloud of electrons. Okay. So I want to draw a picture that looks something like that. Okay, and I want to label it to show that the K plus ions are held in position. They're next to each other. I want to some way represent the cloud of electrons. You could maybe do it with dots. Do it whatever way you think best shows me it. And then down here you want to describe the bonding that happens there. Okay? So the ions have what type of charge? They have a positive charge. And the electrons have what type of charge? Negative charge. So what type of force exists between the two? An static force of attraction. So there's an electrostatic force of attraction, an electrostatic force of attraction between the metal ions and the cloud of electrons that's there. So
Can
if
you write that?
So there's an electrostatic force and attraction between ions plus electrons. Okay. So that's 3 marks. That's a lot of effort for 3 marks, isn't it?
You'd expect at least 30.
So
No,
3 marks. So a diagram, you know, the diagram might be gives you 2 of the marks, but you have to say electrostatic force of attraction between atoms.
You do one for the
between-
diagram, one for the labels, and then one for the.
Yeah.
So
Something like
have
that.
like say if like that we diagram at the end of the lines, but
Yeah, so just don't write electrostatic force of
Between
attraction.
ions.
Say the ions are held to the cloud of electrons surrounding them by the electrostatic attraction because the ions are positive and the electrons are negative. So write as much as you can.
what? Say it again, please.
So electrons or metals are held to the electrons by electrostatic forces of attraction, and all of the ions are held to all of the electrons. They're all held in place by these electrostatic forces. Right. So next we have draw a dot and cross diagram showing outer electrons only to explain the formation of magnesium oxide, MgO, from magnesium and oxygen atoms. Okay, so what I want here is I want my periodic table. Okay, and I want to say magnesium is in what group? Group 2. How many electrons does magnesium want to lose? Not even that. How many electrons does it have in its outer shell? It has 2. So magnesium, it's group 3. It only asks me for the outer ones, but I ain't going to draw them all because I'm sad. So magnesium 1s2. So the first one, top, remember? Second one, top, 3, 6, 9, 3, 6, 9. And it's in the third row of the periodic table, so it has a third row here. And it's top. Yep. Oxygen over here. Oxygen is in the second row of the periodic table, so it has 2 shells, top, and then how many electrons does it have in its second shell? 6. How do you know? Because if you go 1, 2, 3, 4, 5, 6 electrons, you find oxygen. So 1, top, 2, 3, 4, 5, 6. Okay? And what happens? The magnesium says, I don't want these electrons, you can have them, so I'm going to draw an arrow showing that the electron is transferred completely over to the oxygen. And the second one, the electron is transferred completely over to the oxygen. I'm going to draw a wee line, a wee arrow to show me there's a reaction happening. And then I'm going to draw out Mg. Mg, put it inside some square brackets with a wee plus beside it.
Drawing just the last.
So we got with nothing.
That's the point. That's why I as soon as it said outer electrons only, I went, I'm not doing that because it won't make sense to me. I don't want to write Mg and a plus beside it. I want to write Mg. Is it plus?
Yeah.
Is it?
Yes,
2 plus.
2 plus.
Yeah.
Mg 2 plus. So and then
So we draw all
oxygen.
shells.
So you can't go wrong. It's how much extra effort did it take me to draw them all? Really, it didn't take me that much time.
Yeah, I was thinking it, but you're marking it, so if somebody says, oh, you didn't follow what the question says.
If no, you can't be punished for doing more than the question asked. You can be punished for doing less of it, but not more of it. So if I had have written this, would you have liked it?
Well, that's what I've done. What, I don't know, we circle around the empty, just show there's nothing.
To show there's nothing?
Yeah.
But if, well, do it my way.
Do
Do it my way.
the bracket things outside the answers thing too?
Yes, you
Yeah.
do. So 1, 2, 3,
Yeah.
4, 5, 6, and then these are X's to show me that they came from the magnesium. And what's the charge?
Mine.
2 minus.
2 minus.
Anything else or is done?
That's it.
That's that. So we'll go past exam.
It's 8 o'clock. So draw outer electrons only for calcium chloride. Can we skip it? Yeah? Is everyone happy if we skip it?
Yeah.
So I'm going to draw 1 calcium and how many chlorines? 2, and one of the electrons goes to one chlorine and the other electron goes to the other chlorine. And then I draw, so calcium inside a wee box with this, and then chlorine with a Cl and its wee electrons. Like this. And I write minus, but there's 2 of those. Yeah? So use dot and cross diagrams, outer shells only to represent the bond in the nitrogen. So where's nitrogen on the periodic table?
See where that's in bold outer electron shells only?
Yeah.
That's what
Yeah.
it's like. It's
Because,
not
oh,
highlighting
no,
it.
it's because, I'll show you why now. It'll make sense when I draw it on the board, okay? So nitrogen's in what group? Group what? 5, which makes it a metal or a non-metal.
No.
So what type of bonding happens between 2 non-metals? Covalent. So I've got nitrogen. How many electrons in the outer shell? 5. 1, 2, 3, 4, 5. And another nitrogen over here. 1, 2, 3, 4, 5. So they're going to share their electrons. How many does he need?
3.
How many does he have to share?
3.
How many does he need?
3.
How many does he have to share?
3.
3. So I draw 2 overlapping orbitals with an N in each one. He kept 2 of his own electrons, he's not sharing them 2. He kept 2 of his own electrons, he's not sharing them 2, but they're sharing the other 3. There we go.
Yeah.
Okay? So if it's covalent, you definitely only need to show the outer ones. If it's ionic, the reason that I like to show at least the one beneath the outer ones is so that I can show that there's a full outer shell.
So this is.
This is for covalent. So if it's covalent, only show me the outer ones. And then it's the same type of question again. It's hydrogen sulfide, which is basically water. The exact same as instead of having an O, we have an S. It's exactly the same. So quickly, hydrogen sulfide, it'd be hydrogen, a sulfur in the middle, and another hydrogen on the other side. And what I get formed is a big sulfur in the middle, a hydrogen here, a hydrogen here. Sulfur needs to share how many electrons? He has to share 2, so he keeps 2 for himself. He shares 2. Keeps 2 pairs in it. Keeps 4 for himself. So this is what I want to draw. Okay, so a sulfur in the middle, sharing an electron with this hydrogen, and so a hydrogen on the other side, and sulfur sharing an electron with him.
You don't need no plus or minuses or.
There is no
boxes
pluses or
anything.
minuses because it's covalent. They remain uncharged.
So you get one for writing covalent.
Sorry.
You don't need
Doesn't
writing
ask you,
covalent.
but why not? Stick it down. Not gonna, it's gonna, what is it? C-O-V-A-L-E-N-T, 8 letters. Stick down as much as you know. As much as you know. Do you need me to balance equations? Are we okay with them?
They will be 5 maybe.
So make sure you can definitely balance equations.
So see there, you don't really have the space. You don't have the space to write no way.
Do it on
Yeah,
this
whatever scrap
paper.
they say, yeah.
So not scrap. Ask them at the start of the test. If you're not given a booklet, ask them for a booklet.
See, whenever we had our English, no, was it the maths one? We were given like blank, like individual pages. It
Aye.
was the booklet for the English, but it was individual.
Pages. That's
Pages.
okay. You put them
Put them
inside.
inside
and-
your answer booklet,
Yeah,
your test
and
booklet.
they'll be given to me.
Yeah.
I'm happy. I'd be happy with you to answer every single question in the
Yeah.
booklet because I'm very pernickety and a wee bit on the scale, I have to say. I don't like writing on big dark lines. I like writing on nice faint lines. Very sad, I know. Numbers have to be in black, letters have to be in blue. Very sad. Definitely on the scale somewhere. So I don't need to balance equations with you?
No.
No? Renata?
No.
Write it out.
Okay, so write balanced equations for these. So lithium bromide. Lithium bromide is made up of lithium and bromine. So lithium group 1, bromine group 7. Do I need to do this or are you okay
Yes.
with this?
We do 1.
Right. So lithium bromide. So the easiest way to answer something like this, so it says lithium bromide. It sounds like there might be a lithium in it and a bromine in it. Yeah, lithium bromide. Chlorine is Cl. Lithium chloride is Li and Cl, lithium and chloride. Yeah. And the last thing there's bromide. So bromide, does that say chloride or it says chloride? Okay. So if it's an ide, it means what?
Chlorine. Chlorine. Yeah.
Chlorine and bromine.
Yeah,
And bromine.
there you go. That's wrong. Oh, it says bromine. Sorry. Right, chlorine
Valuable.
and bromine. Okay. So lithium bromide. So for these two, I have to make sure that they're balanced. Okay. So I'll bring up a periodic table, and I'll say lithium is group 1. How many electrons does it want to lose?
1.
So it's going to form Li plus. Bromine is in group 7. What does it want to do? It wants to take 1 electron, wants to form Br minus. Do they match?
Yeah.
So it's LiBr. Yeah? Chlorine exists as what? As Cl2, a diatomic molecule. Okay, so it can't be Cl. Cl on its own doesn't exist, it has to be Cl2. Lithium chloride, so we already know lithium is Li+, chlorine is in group 7, so it wants to do what? It wants what? Gain one, so Li-, we're balanced, so LiCl, and bromine is Br2. Remember, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and styrene all exist as diatomic pair, and hydrogen all exist as 2. H2Cl2, Br2, I2, always 2.
Which
Okay.
ones?
Nitrogen, oxygen.
Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, styrene, and hydrogen.
Okay.
Okay, so now I have to see am I balanced. So, is it okay from this point?
Yeah.
So what I do is lithium, I've got one of them, bromine, I've got one of them, chlorine, I've got 2 of them, lithium, I've got one, chlorine, I've got 1, bromine, I've got 2. It's not balanced. I put a 2 here, I put a 2 there, and I'll go away.
That's it, yeah.
Yep.
Yeah.
Okay. So what do I understand by the following terms? A coordinate bond. Okay? So I'm not going to write it down. So it's recording me. I'm going to stand in front of the camera and I'm going to say it. A coordinate bond is a special type of covalent bond. Okay? So if it's my answer would be a coordinate bond is a special type of covalent bond. Covalent bonds are the sharing of 2 electrons between 2 atoms. Usually, the electrons come 1 from each atom, but in a coordinate bond or a dative covalent bond, this is another term for it, both electrons come from one of the atoms. For this type of bond to form, you have to have a non-bonding pair, and you have to have a vacant orbital. Okay? So that may sound all fancy pants to you right now, but it's not really. Here's water. Okay? So this line means there's a covalent bond there. 1 electron from the oxygen, 1 electron from the hydrogen. And over here there's 1 electron from the oxygen and 1 electron from the hydrogen. If I look at the periodic table, I will see that oxygen is in group 6. So it has 6 electrons to itself. So it has 4 electrons that it doesn't share. And these things are called non-bonding pairs. Okay? Now, floating around somewhere up here, I have a H+. H+ is an acid. How many electrons are there in H+?
1.
None. It has a plus. So it has this orbital and there's nothing in it. So what happens is this non-bonding pair says, I lend you these 2 electrons, and what I get formed is this. So 1 electron from each, 1 electron from each, both electrons from the oxygen, and 2 electrons left over. Okay? So this is a coordinate or dative bond. Okay? So how many marks was that worth? So that's obviously far too much information to get 3 marks. But if you can put it all down, then brilliant. Okay? So coordinate bond, special type of covalent bond. Covalent bonds are the sharing of electrons in a coordinate or a dative bond. Both electrons come from the same atom. Okay? Those are the things. Those are your 3 marks, most likely. So hydrogen bonding. What is a hydrogen bond? Okay, I've just thought of something else. So if it was me doing this test right now, as soon as I read that question, I'd go back up here and I would write, this is an intramolecular bond. Okay, so my next question is about intermolecular bonds. bonds between the molecules. So I would immediately go back up and I'd say this is intra, and I go down and I would say hydrogen bond is a type of intermolecular bond. So intermolecular between molecules. It's the strongest type. And for it to happen, you have to have hydrogen attached.
So strongest type of bond.
It's the strongest type of intermolecular bond. Strongest type of intermolecular. Okay? Hydrogen attached to an electronegative atom. And the electronegative atom, it has to be a strongly electronegative atom. It's either oxygen, nitrogen, or fluorine. So you only get hydrogen bond whenever you have an OH, an NH, or an FH. Okay? Is that okay? Any questions? None that you want to ask me? No? Right, I'll do another wee bit and then I'll take a break for 5 minutes to get some breath.
What
Okay.
about B question? 4B.
Ammonia.
Yeah.
Oh, ammonia has high water solubility. Draw diagrams to represent the two ways in which a molecule of ammonia can be attracted to a water molecule, showing all partial positive charges and lone pairs. Right. Okay. Ammonia. What is the formula for ammonia, somebody?
And
N
hash 3.
NH3. NH3. Water is H2O. So I'm going to draw each of them out. Nitrogen. It's got a hydrogen. It's got a hydrogen. It's got a hydrogen. How many electrons? Okay, so this is what I would draw. If I had space to draw, this is what I would draw. What does that mean? What I've just drawn? This thing. Sharing of electrons, okay? So I'm being given more detail than I need to, but I'm going to guarantee that I screw every mark out of this exam that I can, okay? So these are the sharing of electrons in that bond. Nitrogen has 2 electrons left over that it's not sharing. It has 5. So 2 here for itself, and 1, 2, 3 that it's willing to share, okay? Water, oxygen, hydrogen, hydrogen. Oxygen has 2 lone pairs that it keeps for itself, and it shares an electron with each of the hydrogens. Okay? Which is the electronegative part here? Here? Nitrogen. So nitrogen has a delta negative. Hydrogen has a delta positive. Yeah. Oxygen has a delta minus, and the hydrogen has a delta positive. Okay? So I've got hydrogen attached to an electronegative atom, okay? And I've got hydrogen attached to an electronegative atom, okay? Really what I've got is oxygen, and oxygen keeps all the electrons for himself, and I've got a hydrogen that basically doesn't have any electrons, okay? So if I imagine this, it would be hydrogen, and it would be nothing surrounding it, okay? So the ammonia comes along, and the ammonia says, here you can have 2 of mine. Now it's not a dative covalent bond it's forming, okay? What I would draw is a line coming from the lone pair here, the delta negative of the oxygen, lending this positive guy some of its charge. Okay, so that's one way. It can go from the lone pair of the oxygen to the hydrogen, or what else? Or from the lone pair of the nitrogen to the oxygen, to the hydrogen on the oxygen. So this is one way that it can happen here, and the other way that it can happen is H, O, H, and what I'm doing. here, I'm showing it that way. So I would draw a hydrogen bond as a dashed line. Or you can draw it as a line and say H bond. Okay. So the reason that ammonia is so soluble in water is because the ammonia can donate to the water and the water can donate the ammonia. Go. Is there a question there? No? Right, define the term relative molecular mass. What is the relative molecular mass? It is
The one carbon atom.
It is the mass of 1 mole of the material compared to the mass of 12 grams of carbon 12. Okay? So you have to say compared to 12 grams of carbon 12. Jesus, stop pen. So it's remember there's all isotopes in it, so it's the relative mass of the material, the relative mass of 1 mole of material compared to that of 12 grams of carbon 12. So relative mass of the material compared to 12 grams of carbon 12. Right. Potassium dichromate has the formula K2Cr2O7. Calculate the relative molecular mass of potassium dichromate. So K2Cr2O7. So I have 2 times K, 2 times Cr, and 7 times oxygen. That's equal to 2 times K is 39, Cr is 52, oxygen is 32. Yeah, 16. What's wrong with me? 16. So I multiply these together, so that gives me 78. This gives me 104. 70, 100 and what?
12.
112. Add them all together. 180, 284.
94.
294, yeah. 294. Okay? Is that okay?
Write all that in 2 lines. Yeah, fair enough.
No, that's the thing. If you can't write it in 2 lines, then put it on the extra pages. But if you're using extra pages, make sure you're saying question 5, part B.
And write on here C extra or C.
Yeah,
C loose,
make
C
sure,
loose.
but do that at the end.
Yeah.
So do that when you're checking your work at the end, then go through it and do that. I'll do the donkey work if I have to. You just worry about getting the answers. Right, 2.84 grams of potassium dichromate was dissolved in water in a solution made up to 250 ml. In a volumetric, calculate the concentration. Okay, concentration. As soon as I hear concentration, what do I write down? Moles equals
Volume times concentration.
Concentration
divided by 1,000. Okay, and then I'm given some information here. So I'm told I want to calculate concentration. So I'm going to rearrange. I'm going to say moles times 1,000 equals volume times concentration, and then bring my volume across to get moles times 1,000 divided by volume equals concentration, and then I'm going to put in my numbers, see what I know. So 2.94 is that? So 2.94, I'm not told the number of moles, I'm told the volume. So it's moles times 1,000 divided by 250 equals the concentration. I'm not told the number of moles, but I'm told the mass. Okay, so moles equals mass divided by RFM, and that is 2.94 divided by 21. 21 what? 294, I've forgotten what it was.
What worked out in the previous
Ah,
question?
yeah,
294.
294, so that just happens to be 0.1, 0.01.
Yeah, 0.01.
0.01. So this is my number of moles. I can come down here, put my 0.01, multiply by 1,000, divided by 250, and my answer equals, so that's 10 divided by 250, 0.04. Yeah? 0.04 what? Moles per decimeter cubed. MOL dm to the power of -3. So how many marks is that? That's 3 marks. So there's a wee bit of work to do there from the 3 marks. But that's what you have to do. Okay?
What the 2.94?
It says it here in
This is
question.
there, look. Oh, right.
Okay?
Yeah.
Right, paracetamol can be synthesized by reacting 4-aminophenol with acetic anhydride according to the following equation. What mass of paracetamol could be obtained from 4.5 grams? Oh, it's just time consuming this. I'm going to take a break after this because I need a bloody drink. Right, what do I need to do? What mass of paracetamol, okay? So I need to work out moles. I can't work out in mass, I have to work out in moles. The ratio is 1 to 1 to 1, yeah? So it's 1 to 1 to 1. So whatever number of moles of this I start off with, I'm going to equal the number of moles of that, yeah? With me? So moles paracetamol equals mass divided by RFM. Does it give me the RFM? Please God tell me it does. No? Right, see, carbon, I've got 6 of them. Hydrogen, I've got 7 of them.
Yep.
4,
Yep.
5, 6,
Yep.
and 7. And
Nitrogen and oxygen.
nitrogen 1 and oxygen 1. Yeah? So this is 12 times 6, 1 times 7, 14 times 1 times 1, and 16 times 1.
So not.
66.
What? So you're doing the first one. You're doing just the first wee bit of it. Oh.
$109?
What is that? 30.
What? Oh, that was me doing a sum.
It's only 6. Yeah. What? So there's no 2 hydrogen and hydrogen at the end.
Here.
4 2.
So there's 4 here, and there's another 2, and there's another 1. So 4, 5, 6, 7. Is it 109, Sinead? Yep. Okay, so moles equals mass divided by RFM. I've just worked out the RFM is 109. I'm told the mass is 4.5. So 4.5 divided by 109 equals
0.04. If we're going to it's 1, 2, 8.
okay, so it tells me 1
1.05.
decimal place at the end, but I'm going to keep more than 1. So 0.04,
1, 2, 8.
1, 2, 1, 2, I'll go 1, 2, and I'll work it out at the end, okay? So the moles of this is 0.0412. What's the moles of this?
0.0412.
0.0412. So moles of so this shouldn't be paracetamol, should it? That should be amino. So moles para equals 0.0412. Mass of para equals, so I'll rearrange the equation over here, okay? So moles equals mass divided by RFM. So mass equals moles times RFM. And that equals 0.0412 multiplied by the RFM. I have to calculate what the RFM is. So it is 2 carbons, 1 oxygen, 3 hydrogens. 2 carbons, 1 oxygen, 3 hydrogens. 14 times. Is that right? Someone check my maths here. So I have 8 carbons altogether now. 6, 7, 8. Hydrogen I have 4, 5, 6, 7, 8, 9. I've got 10. I've got 10. It should be 9. Oxygen I've got 2. And nitrogen I've still got 1, 4, 5, 6, 7, 8, 9, 9. Right. So 12 times 8 is 96, 9, 14, 32. Have you got it, Sinead? No?
Plus 32, yeah, 151.
150. So
151.
151?
Yeah.
Sounds right. Okay, so mass equals moles times RFM. RFM is 151, so I multiply these two numbers together and I get
Times
6 point something.
6.2212.
6.2212. It says, so this is what I write down, okay?
One is
And then below it, I'll change it to decimal places. I'll write 6.2.
That number is of
The mass. So this is mass of para.
So we didn't really need to work out that
Alright.
first bit, it just was that second part we should have done.
No, you have to do this bit because you have to
Oh,
work out the number of moles.
yeah.
So you have to work out the number of moles. So the moles is 1 to 1 to 1.
Yeah.
So you need to know the number of moles of this, and then you carry that number across and say
Oh,
that's
yes,
the
because
number of
you've been
moles
told
of
what
that.
the grams is of that.
Okay.
Yeah.
So again, how many marks are we worth there?
5, 6,
6 marks. So a wee bit of effort there, and you can see it's a wee bit of effort. Okay. Right. I'm going to take 5 minutes to drink some. Actually, I'll just go for a smoke.